तो हमारा पहला क्वेश्चन आज का है क्वेश्चन नंबर 27। ओके, हम लोग क्वेश्चन नंबर 26 तक कर चुके हैं। सॉइल मैकेनिक्स हम लोग कर रहे हैं, चैप्टर 1 कंप्लीट कर रहे हैं। इंजीनियरिंग सर्विस PYQ। ओके, इंजीनियरिंग सर्विस एग्जाम PYQ हम लोग कंप्लीट कर रहे हैं, 26 तक कंप्लीट कर चुके हैं। हम लोग 27 से स्टार्ट कर रहे हैं। तो क्वेश्चन नंबर 27 में क्या बोल रहा है, देखते हैं। ड्राई सॉइल, let me select the pen. Okay. Okay. A dry soil sample has equal amount of solids and voids by volume. So equal amount of solid. This means it is saying that Vs is equal to volume of solid is equal to volume of voids. Okay. Its volume, its void ratio and porosity will be. So void ratio is nothing but E is equal to volume of void by volume of solid, and both these quantities, volume of void and volume solid, equal. Therefore this ratio will be 1. Okay, similarly porosity, you know that porosity eta is equal to E divided by 1 plus E, so that is 1 divided by 1 plus 1, that is 1 by 2, and this is 50%. Okay, so void ratio is 1 and this is 50%, so option number D, 27, option number D is the correct answer. Okay, now next question, क्वेश्चन नंबर इसको क्लियर करते हैं. ओके, नेक्स्ट क्वेश्चन इज क्वेश्चन नंबर 28. ओके, so question number 28, the plasticity index and the percentage of grain size finer than 2 micron of clay sample are 25 and 15 respectively. Its activity ratio is. So you know that activity is equal to plastic index IP divided by percentage finer finer than 2 micron, that is clay, that is clay. Okay, so this is IP is given 25. IP is the percentage grains 2 micron of clay sample at 25. So this is IP is 25 and this is 15. So 25 by 15 is 5 by 3. This is equal to 2, sorry, 1 point. This is equal to 1.67. So option B is the correct answer. 28 done. 28 is done. Now 29. 29. So a soil sample having a wide ratio of 1.3. So E is equal to 1.3. Water content is 50%. Water content W is equal to 50% means 0.5. Okay, and a specific gravity of GS is equal to 2.60. Is in a state of partially saturation, full saturation, over saturation, under saturation. So you have to calculate value of S. So you know a well-known formula. SE is equal to G into W. So here S is saturation, S is degree of saturation. Okay, E is void ratio, G is specific gravity, W is water content. So S is equal to G into W divided by G into W divided by E. So G is what? G is 2.60 into W is 0.5 and divided by 1.3. So this ratio is, if you multiply these two, you will get 1.3 divided by 1.3 is equal to 1. So S is equal to 1, therefore degree of saturation, S is equal to 1, therefore degree of degree of saturation, is equal to 100%. That is full saturation. That is full saturation. Option number B. 29. Next question, question number 30. The natural void ratio of a sand sample is, question number 30. The natural void ratio of a sand sample is 0.6. Natural void ratio, suppose En is equal to 0.6, and its density index ID, is also 0.6. If its void ratio in the loosest state is 0.9, so E maximum in loosest state, the void ratio will be maximum. So E maximum is 0.9. Then the void ratio in the densest state, the void ratio will be minimum void ratio. So you have to calculate E minimum. Okay. So formula for that is ID is equal to E max minus En natural void ratio divided by E max minus E min. Okay. In this case, ID 0.6, it is given, is equal to E max, it is given 0.9, minus En is given 0.6, and divided by E max is 0.9 minus E min. Okay. So this is 0.9 minus E min is equal to 0.9 minus 0.6 is 0.3, and divided by, we take this one this side, and we take this side. So this is 0.6. So 0.9 minus E min is equal to 0.5. So E minimum is equal to 0.9 minus 0.5 is equal to 0.4. So C will be the answer. The next question is, question number 31. Question number 31. Which one of the following phase diagram represents a clay at the shrinkage limit? Okay. At the shrinkage limit, we always draw this graph. This one. We always draw this graph. Okay. This is shrinkage, water content as shrinkage. This is plastic limit, shrinkage limit, and this is liquid limit. Okay. And this is volume, and this is water content on this side. So this is At shrinkage limit, the degree of saturation is always 1. Okay. So if degree of saturation is 1, so the soil will be in two-phase system. Okay, soil will be in two-phase system. What is WS? WS is nothing but maximum water content, maximum water, maximum water content at which reduction in water, reduction in water, reduction in water content, reduction in water content will not cause a decrease in the volume of soil mass, will not cause a decrease in the volume of soil mass. Okay. So key characteristic of soil at its shrinkage limit includes key characteristic key characteristic of a soil at its shrinkage limit includes first, the soil is completely saturated. The soil is completely saturated. Okay, there is no air present in the voids. Same thing. There is no air present in the voids. And third one, if any more water is removed, if any more water is if any more water is removed, air will start entering, air will start entering, air will start entering the void. The voids. But the total volume of the soil, but the total volume of soil will remain constant, will remain constant. Okay. So at shrinkage limit, uh, the soil is completely saturated, and the soil will have two-phase system, water and solid. So option B will be the correct answer. Okay. Now we will see question number 32. Question number 32. Which of the following correctly represents the dry unit weight of soil sample which has a bulk unit weight gamma T at a moisture content of W%? Okay. So gamma D is gamma T divided by 1 plus W. Okay. And here W is in percentage. So that is gamma T divided by 1 plus W in percentage divided by 100. So this is 100 gamma T divided by 100 plus W in percentage. So gamma T, so option will be gamma T 100 divided by 100 plus W in percentage. So this is option number C. Correct to option number C. Okay, very simple. Now question number 33. Question number 33. In this question, coefficient of curvature is CC is equal to 1.4. D30 is equal to 3 mm and D10 is equal to 0.6. Based on this information on particle size distribution, for the use as subgrid, this soil will be taken to be. So remember table. This question is based on a table. This is well graded gravel, well graded gravel. Well graded gravel is GW and poorly graded gravel. Poorly graded, poorly graded gravel, GP. Okay. So first, for soil to be well graded gravel, the first condition is more than more than half of more than half of coarse fraction coarse fraction must be greater than 4.75 mm. And second condition, Cu is equal to what? D60 by D10, and that must be greater than 4. And third condition, coefficient of curvature, that is D30 square upon D10 into D60 must be greater than, must be lie in between, not greater than, must be lie in between 1 to 3 cc. Okay, must be lie in between 1 to 3. That is cc lie between 1 to 3. Okay, and otherwise, if these condition is not fulfilled, then the soil will be what? Poorly graded soil. Otherwise, okay. So this table is, this question is based on this table. Okay, and for sand, well graded sand, there is another table for well graded sand. This is well graded gravel, and if we take well graded sand, then I am writing it in black. Okay, if this is sand slash sand, so it is GS. Well graded sand is SW. Very sorry. This is well graded sand. Sand is well graded W. So SW. Okay. So this ratio will be greater than 6, and this number is less than 4.75 mm. Okay. So so otherwise, this is um, poorly graded sand, that is SP. Okay. So if we remove uh, these things, then the table for sand, okay, SW, that is poorly graded This is sand. This is sand. This is sand. Okay. We will remove this less than and less than 4.75 m, and it must be greater than 6, and this remains the same 1 2 3. Okay, otherwise, so these two tables you have to remember to solve this problem. So coming to this problem, CC is 1.4, so this lies in this range, and we have to calculate CU so that we can see this condition. So for CU is D60 by D10. We have to calculate D60. So from CC here, CC is D30 square by D30 square by D10 into D60, and CC is 1.4, that must be equal to D30 square. D30 is 3 mm, so that is 3 square divided by D10 is 0.6 into D60. From here, D60 is equal to 3 3s are 9 divided by 0.6 into 1.4, and result is uh, this result is uh, so this is D60. So Cu is what? Cu is D60, that is 9 divided by 0.6 into 1.4 and divided by D10, and D10 is 0.6. So that is Cu is, we apply this formula. So D60 by D10 0.6. So this is, when you solve this, you will get, when you solve this, you will get 17.85. Okay. So Cu is greater than 6, and Cu is greater than 6, and Cc is in between 1 to 3. So in this case, Cu is greater than 6 and Cc is in between 3 to 1. Okay. So given that, coming to D10, based on information, particles are distribution. Uh, sand, every is sand, so you don't need to check this criteria. From second and third criteria, you can say that this is what, well graded sand. Well graded sand. This is well graded sand. Okay. So next question is question number, next question is question number 34. Question number 34. Okay. What is question number 34? Which one of the following represent relative density of saturated sand deposit having moisture content moisture content of 25% if maximum and the minimum wide ratio of sand are this and this? So Emax is 0.95, Emin is 0.45, and the relative density of saturated sand deposit having moisture content is, and W moisture content is 25%, and the specific gravity G is 2.6. So what uh, is asking in the question is which of one will represent relative density of saturated sand. So relative density, for calculating relative density, and the specific gravity is this. So you have to calculate natural void ratio. So En, you must have to find En. Which one of the following represent the relative density? So in ID, relative density, E max minus En divided by E max minus E min. So E max is given, E min is given. So you have to calculate first En. Okay. So for En, SE, then apply formula SE is equal to G into W. So what is S? Let me read this question again. Which one of the following represent relative density of saturated sand? Okay. This is given saturated sand. So saturated sand means S is 1. Okay. So E is equal to G is 2.6 into W is 25%, 0.25. Okay. So 2.6 into 0.25. So if you multiply 2.6 with 0.25, you will get 0.65. Okay. So from here, ID is equal to Emax. What is Emax? 0.95 minus En. You've calculated just now. 0.65 divided by Emax is 0.95 minus E minimum is 0.45. So this value will be 0.30 divided by 0.50 is equal to 3 by 5 is 0.6. It implies that 60%. So this will be the answer. Now next question. Now next question is question number 35. Assertion A is saying that a soil is at its liquid limit if the consistency index of the soil is equal to 0. So what is consistency index? Consistency index, IC. We have discussed, studied that consistency index, IC, is liquid limit, WL, liquid limit, WL minus natural water content, uh, WN, divided by liquid limit minus plastic limit. Okay, this is consistency index. This is volume, this is water content, this is the curve. This is shrinkage limit, this is plastic limit, and this is liquid limit. Okay, so this ratio will give you IC. So it is saying that a soil is at its liquid limit. अगर liquid limit पे soil होगा, then WN will be what? WL. Then WL minus WL is 0. Therefore, if IC is equal to 0, this implies WL is equal to WN. Okay. So assertion is correct. Reason, what is reason? The consistency index of a soil is defined as ratio of liquid limit minus the natural water content divided by natural water content minus plastic limit. No, this is liquid limit minus plastic limit, not natural water content minus plastic amount. So this statement, the reason is wrong. This is wrong. So option number C. Okay, statement, the assertion is correct, but the reason is wrong, incorrect. Okay, so option number C will be the correct answer. Next question. Question number 36. Consistency as applied to cohesive soil is an indicator of its density, moisture content, shear strength, and porosity. So consistency, what is consistency? Uh, Cohesive soil consistency as applied to cohesive soil is an indicator of its shear strength, because you know a table uh, of consistency index versus uh, the soil is semi-solid or soil is stiff, medium stiff, soft. So these all uh, stages of consistency will depend on value of IC. Okay, write me that table. IC and IL. This is consistency index and this is liquidity index. Okay, and IC plus IL is equal to 1. So if IC is greater than Z 1, if this is greater than 1, then this is less than 0. Okay, and this is consistency. This is consistency. So for this condition, consistency is semi-solid to solid. Semi-solid to solid. Semi-solid to solid. Or extremely stiff, hard. Extremely stiff or hard. Okay. And if it is 1 to 0.75, if consistency index 1 to 0.75, then IL liquidity index will be in the range of 0 to 0.25. So the consistency will be stiff to very stiff, stiff, stiff to very stiff to very stiff. Okay. And if this is 0.75, if IC is in between 0.75 to 0.5, then IL will be in the range of 0.25 to 0.5. Then the consistency will be medium stiff. Medium stiff. And if it is IC in the range of 0.5 to 0.25, then IL will be in the range of 0.5 to 0.75. Then the consistency will be soft. And if IC is in the range of 0.25 to 0 and IL liquidity index is in the range of 0.5 to 1, and this is the consistency will be very soft. Very soft. And if IC is less than 0, then IL will be greater than 1. And in this case, consistency will be liquid state. The soil will be in liquid state. Liquid state. Liquid range. Liquid range. And for this, this is plastic range. Plastic range. Okay. And it is solid to semi-solid range. So consistency as applied to cohesive soil is an indicator of what? Shear strength. Okay, in this case, shear strength is very less, that is 2.7 kilonewton per meter square in liquid state. At liquid limit, not at liquid state, at liquid limit. At liquid limit, shear strength is 2.7 for all soils. For all type of soil at liquid limit, the shear strength of soil is very low, that is 2.7 kilonewton per meter square. Okay, so this is question number 36. Now question number 37. Question number 37. While computing the values of limits of consistency and consistency indices, it is found that liquidity index has negative value. Consider the following comment on these values. Liquidity index cannot have negative value and should be taken as 0. So this statement is wrong. Okay, so this liquidity index may have negative value, and in this case consistency will be semi-solid to solid. Okay, it is brittle, very brittle, extremely stiff or hard. Okay, तो लिक्विडिटी इंडेक्स अगर 0 से कम होगा तो कंसिस्टेंसी जो होगी सॉइल की वो सेमी सॉलिड टू सॉलिड होगी, एक्सट्रीमली स्टिफ और हार्ड होगी. सो दिस स्टेटमेंट इज रॉन्ग. Liquidity index may take negative values. Okay, so this statement is wrong. Second statement, liquidity index can have negative values. Yes, it can have negative values, and if it has negative value, then consistency index will be greater than 1. And in this case, consistency of soil will be semi-solid to solid, extremely stiff or hard. Okay, so this statement is correct. And statement 3, what is this? The soil tested is in semi-solid state and stiff. The soil tested is in semi-solid state and stiff. But this statement is, while computing the values of limit of consistency and consistency indices, it is found that liquidity index have negative value. If it has negative value, then the soil is in semi-solid state and stiff. Yes, this is correct. This statement is correct. So this statement is correct. Fourth, the soil tested is in medium soft stage. No, this is not soft stage. In soft stage, the liquidity index have positive value and it is in the range of 0.5 to 0.75. Okay, so this statement is wrong. I am writing this again. IC and IL and consistency. So statement 1, liquidity index cannot have negative values. So in previous question, if this is greater than 1, then this is less than 0. So this is this case. Statement 1 is this case. Then what was the consistency? It was semi solid to solid or extremely extremely stiff slash hard. Okay, and second, liquidity index can have negative value. Yes, can have negative value. And third is the soil tested in semi solid, and yes, correct. And fourth one, the soil tested in the soft medium soft. So for medium soft, this this value has liquid index have positive values. Okay, so this is incorrect. So option 2 and 3, option number D is correct. Okay, now question number 38. The collapsible soil is associated with dune sand, laterite soil, loess, black cotton soil. Dune sand and loess has some common properties, like dune sand is a wind deposited soil And loess is also a wind deposited soil. But loess in loess uh, soil, a honeycomb like structure will form. And in case of honeycomb structure, it is like that large voids present in the soil. It's arranged like this. Soil make a very large voids. Okay, so if these voids break, a sudden change in a sudden settlement occurs. So due to this soil is called collapsible soil. So the collapsible soil is associated with what? Loess. Okay, question number 38. Now question number 39. Question number 39. Two soil sample A and B have properties Na is equal to 40 and Nb is equal to 60 respectively. What is the ratio of Ea, Eb? So N is E divided by 1 plus E, and E is N divided by 1 minus N. This is not N, this is eta porosity. This porosity is equal to Y ratio divided by 1 plus Y ratio. So Y ratio is uh, porosity divided by 1 minus porosity. Okay. So Ea by Eb, this is equal to Na divided by 1 minus Na multiplied by 1 minus Nb divided by, you take the ratio, I am taking ratio, this divided by Nb divided by 1 minus Nb. So this will be Na into 1 minus Nb divided by Nb 1 minus Na. So Na is what? Na is 40, 0.4, 1 minus 0.6 divided by 0.6, 1 minus 0.4. So 0.4 into 0.4 divided by 0.6 into 0.6. So that is 16 by 36, 4 by 9. So option C, 4 is to 9. Option C. Okay. Now next question is question number 40. Question number 40. Very important question. This is formula based. So dry density gamma D is equal to G plus, let me write the uh, gamma bulk is equal to G plus AC divided by 1 plus E into gamma W. So moist density B, option B, and this is option number 1. So B is nothing but 1. Dry density gamma D, for dry density the saturation, degree of saturation will be 0 for dry density. For dry density, S is equal to 0. This implies that gamma dry is equal to S. Oh, sorry. Gamma dry is equal to G plus 0 into E divided by 1 plus E gamma W. So this is G into gamma W divided by 1 plus E. So G into gamma W 1 plus E 2. Okay. Submerged density. This is B, this is A, this is C. Submerged density. So gamma submerged is gamma sat minus gamma W. And gamma sat for for saturated saturated soil, S is equal to 1. For saturated soil, S is equal to 1. This implies that gamma sat is equal to G plus 1 into E divided by 1 plus E into gamma W. Just put 1 in place of S. You will get this one. Okay. So this is G plus E divided by 1 plus E into gamma W. So this is option number. This is T, saturated density is G plus E divided by 1 plus gamma W. So this is 3. Okay. And gamma submerged is gamma sat minus gamma W. So gamma submerged is equal to gamma sat is G plus E divided by 1 plus E into gamma W minus gamma W. So if you take 1 plus E here, then this is G plus E minus 1 minus E into gamma W. E cancel out. Then this is G minus 1, 1 plus E into gamma W. So G minus 1, this is 4. This is 4. So answer will be 2143. 2143. Option number A. Okay. So this is the basic formula. You must remember. Okay. In this formula, for dry state, for dry state, for dry state, put S is equal to 0. For submerged state, saturated state, for saturated state, put S is equal to 1. And you will get all these formulas. Okay. So remember this formula. Okay. So now next question is question number 41. What this question is saying, what are the respective values of wide ratio, porosity ratio, and saturated density in kilonewton per meter cube for a soil sample which have saturation moisture content means for S is equal to for S is equal to 1 saturation moisture content, W sat saturation moisture content W sat is equal to what? 20%. 20%, that is 0.2. For S is equal to 1. And a specific gravity of grain size G is equal to 2.6. So if we want to calculate wide ratio at this stage wide ratio, so S E is equal to G into W. So S is equal to 1 into E, G is 2.6 into W is 0.2. This is 0.52. So wide ratio at this stage E is equal to 0.52. Okay. The first one, E is 0.52. The next, the value of wide ratio, porosity ratio. So N is nothing but E divided by 1 plus E. So 0.52 divided by 1 plus 0.52 is 0.52 divided by 1.52. And this result is 0.52 divided by 1.52. So if you calculate 0.52 divided by 1.52 is 0.34. 0.34. Okay. Now the next is and saturated density gamma sat. So gamma sat is G plus S. S is 1 divided by 1 plus E into gamma W. So G is 2.6 plus E is 0.52 1 into 0.52 divided by 1 plus 0.52 into gamma W is 9.81. So 2.6 and 0.52 divided by 1.52 into 9.81, and this result, when you multiply this, calculate this, you will get 20.14 kilonewton per meter, kilonewton per meter cube. So option number D will be the correct answer. Now next question, question number 42. Question number 42. Embankment fill is to be compacted at a density of 18 kilonewton per meter cube. The soil of the borough area is at a density of 15 kilonewton per meter cube. What is the estimated number of trip of 6 cubic meter capacity truck for hauling the soil required to compacting 100 meter cube fill of the embankment? Assume that the soil in the borough area and that in the embankment are the same moisture content. So this is fill, this is fill, okay, this is fill, this is fill, and this is borough pit, and this is pit. And moisture content in both are same. Pit and fill, the moisture content is same, but the density of fill is 18. So this is more compacted. Density is 18 kilonewton per meter cube, and volume of fill, compacted fill, is 100 meter cube. And in this case, gamma F, so gamma F लिख देता है, fill, and pit, gamma pit is 15 kilonewton per meter cube. So we have to calculate the volume excavated from pit, that is Vp, is equal to what? Okay, this is Vf. So if the moisture content in fill and the soil which excavated from pit is same, then the mass of soil in fill and the mass excavated from mass of soil excavated from the pit will remain the same. Okay, so from here, mass, what will be the weight of soil in fill is equal to what? Is equal to density times volume, gamma F into Vf. So this is gamma F is 18 kilonewton per meter cube into 100 meter cube is 1800 kilonewton is weight of fill. Therefore, weight of therefore I am changing the color. Therefore weight of excavated soil from pit is equal to 1800 kilonewton. Why? Because the moisture content, because moisture content is same in both, that is pit and fill. Pit and fill. It is written here, assuming this condition. Okay. So this is the weight. So from here, volume of pit, volume of excavated soil from pit will be Vp is equal to, that is weight divided by the density of soil which is excavated from pit is gamma p. This is 1800 kilonewton divided by 15 is equal to is 15 kilonewton per meter cube. And when we take these ratio 1800 divided by 15, then you will get a number 120 meter cube. Okay, and therefore number of trip therefore number of trip number of trip is equal to total volume excavated is 120 divided by capacity of one trip is 6, so that is 20 trips. So answer will be C. Okay, now next question is question number 43. Question number 43. What is question number 43? A clay sample has a void ratio of 0.54 in dry state. So E is equal to 0.54 in dry state. The specific gravity of soil is Gs is equal to 2.7. What is the shrinkage limit of soil? So at shrinkage limit, at shrinkage limit, you can take S is equal to 1. So we can apply formula SE is equal to G into W. So S is 1 into E is equal to G. E is given 0.54. 1 into 0.54. S into E, this is equal to G. G is 2.7 into W. So this is WS, shrinkage limit. So WS is equal to 0.54 by 2.7. So that value will give you answer 0.2. 0.54 by this is 0.2. This implies 20%. Okay, so answer will be D, 43D. Now, question number 44. Question number 44. The laboratory test on a sample yielded the following result. Plasticity index IP is 32%. Liquidity index IL, liquidity index IL is equal to 0.15. Okay, and activity number AC is equal to 1.58. Which of the following inference can be drawn? The first one is the soil is very stiff. Soil is very stiff. So if IL, liquidity index, is 0.15, liquidity index is 0.15. In case of liquidity index 0.15, it is in between 0 to 0.25. Okay, so IL and consistency consistency. So if this is less than 0, semi-solid to solid, consistency is semi-solid to solid, that is extremely stiff slash hard. Okay. And if it is 0.0 to 0.25, stiff to stiff to very very stiff. So 0.15 lies in between 0 to 0.25. So soil may be stiff. The soil is very stiff. This statement is correct. The soil is medium soft. So this is incorrect statement. The soil is highly plastic. The soil is highly plastic. IP is uh, IP is 32. So IP is 32. So IP and the relation between IP and consistency, if this is IP and consistency, then if IP is 0, then this is non-plastic. IP cannot take negative value. If it happens, then we take its value 0. And if it's less than 7, that is low plastic. If it is in between 7 to 17, medium plastic. And if it's greater than 17, that's highly plastic. Highly. So this value comes in this range. This value comes in this range. Okay. So this is highly plastic. So option number 3 is correct one. Statement 3 is correct one. The next is the soil is medium plastic. This is wrong. The soil is active. So for activity number, what is activity number? I am changing the color. Activity number is equal to IP divided by percentage of clay. Percentage of clay in soil. So if AC is less than 0.75, this implies inactive soil. If AC is in between 0. If AC in between 0.75 to 0.75 to 1.25, and this is normal active. And if AC is greater than 1.25, this implies very active. So soil is active. This is 1.58. It is greater than 1.25, and this is soil is active, and this statement is correct one. So 1, 3, and 5 is correct. 1, 3, 5 is correct. So option number A is correct. Okay. 44. Option number A. 44. Option number A. Okay. Now next question is, I'm clearing all. Okay. Now next question is 45. This is same question. We have discussed it already in previous question. And this 45, question number 45 is same as question number 45, and question number 45 and question number 18 is same. Question number 45 is same as question number 18, and question number 18 is asked. Question number 18 is asked in engineering service exam 1998, and question number 45 is asked in exam engineering service exam 2006. So same question, repeating question. This question is, you can solve this as gamma is equal to G plus AC divided by to gamma W divided by 1 plus A. So in this expression, there is no E. So you can eliminate E by the relation SE is equal to G into W. So from here, E is equal to G into W divided by G into W divided by S. So gamma is equal to G plus SE, and SE is equal to G into W divided by 1 plus E. E is GW by S into gamma W. So from here, if you take this side and gamma in the bottom, then you will have 1 plus GW by S is equal to, take G out from this bracket, so G into 1 plus W gamma W divided by gamma. If you divide by G, this is 1 by G plus W by S is equal to gamma W by gamma 1 plus W. If you take this G this side, then this will be W by S is equal to gamma W by gamma 1 plus W minus 1 by G. If you reverse this expression, then you will get S by W is equal to 1 divided by gamma W by gamma into 1 plus W minus 1 by G. So if you take this W this side, so this is S is equal to W divided by gamma W by gamma 1 plus W minus 1 by G. So this is the expression. So this A will be the answer. 45 gamma by W divided by gamma W. No, this is gamma by gamma W. This is gamma W by gamma. So this option D is correct. This is not. This is not correct. Option D is correct. Okay, option D is correct. The next question. Question number 46. Let me take this question in next class. So for today, thank you. We will discuss this question in next video. Okay. Thank you, everyone.